Hi everyone, this is the third in a series of videos where we talk about how to code a ChatGPT model from scratch. In this third and the final part of the video, we want to explain how ChatGPT does a next word prediction. What I have here in this notebook is loaded up a GPT-2 model, one of the earlier variants of ChatGPT, which can run pretty well on a CPU. As you can see, I'm running it on a CPU Colab notebook, and here it runs fairly fast for a CPU to predict a series of next tokens. I've asked it to predict the 30 next tokens from, this prompt that I gave to the GPT-2 model, and it was able to sort of predict the next 30 words or 30 tokens. And it may not be the best model, but it still does a pretty good job. But our goal is to sort of take a model that is small enough so that we can run on a CPU notebook and still understand how it works internally. If you are following along, we had two different videos before, and these videos explained how the first video talked about how the multi-headed attention mechanism worked, which is the most important part of the GPT model. And in the second video, we sort of looked at or put together how the GPT model itself worked. So the GPT model consists of a number of modules, and we loaded a pre-trained model from Hugging Face, and here we have the whole architecture of this model. We looked at each of these layers and how they work, and we looked at how they are coded in Python in this GPT model sort of class. So that is sort of a little bit of background context. I have used two important sort of resources if you want to follow along. One is the Illustrated Transformer from JLMR, which is, I feel like, one of the best resources to learn about GPT. The Attention is All You Need paper, which is the paper that introduced the attention mechanism. And this code here is from the Sebastian Rachka's amazing build a language model, large language model from scratch repository in GitHub, and he has a corresponding book as well. And you can look at all the code from each of the chapters where he sort of goes through the steps of building this model. We're at the final stage where we now have a GPT-2 model where we you can see we've loaded the weights from scratch, and we have we've assigned these weights to each of the sort of variables we have internally in our class, and we have the GPT model class, which in each one of the weights of this class has been assigned from the pre-trained model, which is in the load weights function. And finally, what we have done is we have used this tokenizer, and then we get the token IDs for the next 30 tokens, and then we output this text. So let's look at this function in a little more detail. So it's called generate. It takes the GPT model. It takes the ID X, which is the series of or a vector of IDs of the tokens. So we start with a text, which is our prompt. This is our prompt, and we use a tokenizer, and we call this function called text to token IDs, and this gives us a series of token IDs. Just to make you understand a little bit more, the GPT-2 model has a vocabulary of 50,257 tokens. So those are the tokens that it understands. So the token is sort of either a word or some smaller sort of abbreviation of a word. But let's look at an example. So if I call this function text to token IDs, I called it with some text to token IDs with some text, and then the IDX is simply a tensor which has a series of token IDs. And maybe select has, so there are 50,000 possible tokens, and then the 46,506 token corresponds to the word select. The user ID corresponds to likely the 2836th token, the comma corresponds to the 312th token, and so on and so forth. It may not be exact because sometimes a word is broken down into two by the tokenizer, but that's the idea. So I pass to this function a prompt, which is exactly what will happen if you go to ChatGPT. You enter this sort of question or whatever, like you write on the ChatGPT sort of text box. So that is your prompt. Once you've given this prompt, ChatGPT sort of takes this prompt and processes it into this series of tokens, which is exactly similar to what we have here. And now we ask ChatGPT, how many tokens do you want to produce, which is sort of how many words more do you want to produce. So we started with once upon a time, there was a land, and then we told it to produce 30 more, and it produced these. If you want it to produce more, it will produce sort of more tokens. And then we have to give some like, some fact, like we'll understand more about what these mean, the top K and the temperature. And we will likely, these are factors that we can sort of change around. So this is the generate function. Let's see what this function does. So this is the generate function. I think it's easier to understand a corresponding function called generate text simple, which is a simpler sort of version of this function. And then we will see how this function is slightly more complicated. So the generate text simple, so we call our for loop in like the max token. So that we told the function, please generate 30 new tokens. So for each of these, we will sort of go through a for loop, and in each of these sort of iterations, we will generate one token. The first thing that we do is to crop the context if it's more than the context size. So the context size is like the maximum number of tokens that can be given as an input to the model, and GPT-2's context size is 1024. That's the context size. If you give more than 1024 tokens, we will, this step will sort of crop the number of tokens to the last 1024 tokens. And then with sort of torch.nograd, because we're not training the model here, we will get this logits. And this logits is basically a vector which is 50,257 sized vector. So vocabulary sized vector, and we only want the last one, because the last one, in this case, it produces a vector which is n token multiplied by vocab size, and the batch is 1, so we can just ignore that. And then the vocab size, we want a vector which has a size of the vocabulary, which is, you know, the 50,257, 5257. So, and for each of these words, it gives a probability between 0 and 1, and all of these numbers add up to the number 1. And so, and this is where we have these 50,257 numbers, which are all between 0 and 1. And then we want to produce the next token, which is, and we say, what is the ID of the next token? And we say, what is the maximum value among all these 50,000 words? And that is the ID of the next token. An ID is something like this here, for example. So this is an ID of a token. And then we have a mapping of the ID to the actual word, and then we can use that to sort of convert it back to the actual word. But what do we do next? And this is important. Here we can add this token to the series of tokens here. So how does ChatGPT work? It works by producing the next word. So I give this sort of once upon a time there was a land. In the first iteration, it produced the word off. Once it produced the word off, it adds the token of off to, you know, this tensor here. And then the off probably has some tensor, and it adds that. And once it adds that, it again sort of calls this function with once upon a time there was a land off, and it produces the word the. and that is sort of, it only produces one word at a time. And you can see this in this sort of, in this for loop. The IDX is now the original IDX plus the token that we generated. And then this IDX now goes to the next iteration of the for loop. If we have exceeded 1024, it sort of pulls back one number, and then it sort of keeps going like that. I wish I could show you an example here. Maybe we can. How about we print the IDX? This is inside the for loop, right? So maybe we can do that. Okay. Yeah, so that maybe gives you a pretty good idea here. So we passed this token, we passed this token here, which is, 707454, stands for ones, and so on and so forth. And then in the first iteration, it produced the word off, which has the token of 262. And in the second iteration, it produced the word the, which has the token of 2636. And now it's sort of, after the second iteration, it added these tokens to its to the tensor, and it sort of keeps on doing that. And you can see the tensor is sort of getting larger and larger until it gets to 1024. In this case, it never does, but if we keep on doing this, it will eventually do that. So that is what the next word prediction does, and this is sort of generate text simple. So we understand that, and then finally we return all of these IDs, the final set of IDs. And then in this function here, we says token IDs to text. And then this is the series token IDs is sort of this tensor, and there is a mapping between 7454 to ones and so on, and that will give us the final sort of text, which is this text, right? So okay. So now I think we have a very good understanding of how the generate text works given the ChatGPT model. Now we finally want to understand this generate, which is a slightly more complicated function. And the complication here comes, so this is the same, we produce the logits. And the complication here comes from how do you sample the next one? One way to sample the next token is to keep the top k tokens. So if we say top k, which is not none, in that case we find the top logits, which is the top k logits, like the top 5 tokens, for example. So there is a 50,257 sized vector with numbers between 0 and 1, and maybe you want to find sort of the 10 most probable words, which has the 10 highest sort of probabilities. And those are the top tokens. So if I were to sort of write, I don't know, like a number, and then maybe 0.4, and so on, and then there are other sort of 50,000 numbers here, and then we would choose like these two as like the top 2 tokens, right? And then there we would have the indices of these two words, and then we would sort of try to find one of them. And so if top k is none, this is what we do to the logit. We make the other one 0, and we only keep the top k. And then we can apply temperature scaling, where we sort of try to scramble this a little bit by applying some temperature to add more noise. So that would help the GPT sort of produce sort of newer words. And again, there is a lot of sort of work on what is the best way of doing this, but that's the idea. And then the next token in this case is sort of a sample from the multinomial. So maybe we have 10 tokens with sort of given probabilities, and then we give we sample one token from those 10. But if this is not true, then we go back to our simpler method, which is we take the maximum one. And then if it's the end of sentence, then we just break. If not, we concatenate it to the previous tokens as we did before. So that is what this word does, this generate function does. And I think now we have a pretty good understanding of how ChatGPT is generating a series of words for us by doing a next word prediction. And it's one of the most powerful algorithms that in our time. But thank you for listening. If you have any questions, comment, and don't hesitate to sort of send me a message, and I will do my best to help you answer. Thank you.